It is important to be able to read and write oxidation and reduction half reactions. Let's learn to do it. So here we have the single replacement reaction, and we start by assigning the oxidation numbers to all the ions and elements within this reaction. The cobalt over here and lead over here receive the oxidation number 0 because they are uncombined elements. Chloride ions would always have oxidation number -1 in the compound, and to compensate for it, the cobalt should be carrying the oxidation number +2, as well as lead over here +2 as well. Oxidation is defined as the loss of electrons by an atom or ion. So let's see who got oxidized. Cobalt has oxidation number 0, and over here it's +2. What happened here that the cobalt lost 2 electrons. It gave off the 2 electrons. That's why the charge of this cobalt went up. And let's write oxidation half reaction for cobalt. Cobalt 0 became cobalt +2, and we are writing those 2 electrons that were lost on the product side of the oxidation half reaction, because those 2 electrons that were lost, they are the product of this half reaction. And when it comes to lead, the lead had oxidation number +2, and then the oxidation number actually went down because lead accepted those 2 electrons that were lost by the cobalt. So let's write the reduction half reaction for lead. Lead +2 accepted those 2 electrons that were lost by the cobalt, and it became lead with the oxidation state 0. Oxidation cannot be happening without reduction, and reduction cannot be happening without oxidation. If the electrons are lost, there must be a substance that would be accepting them. Let's look at another compound, at another redox reaction, and we start by doing the same. We assign oxidation numbers, and here we have hydrogen, uncombined element, so its oxidation number is 0, so is the oxidation number of the zinc, and hydrogen would always be +1, Cl in compounds would always be -1, and zinc would be +2. So let's see who got oxidized. The oxidized element must be losing electrons, and its charge should be going up. We have zinc with the charge 0, and over here zinc has the oxidation number +2. So zinc must have been losing electrons, and it was oxidized. So let's write the oxidation half reaction for zinc. It has new oxidation number, and we can see that 2 electrons were lost. And hydrogen must have been reduced because we have hydrogen with the oxidation number +1 on the left, and right here we have hydrogen with the oxidation number 0. So for the reduction half reaction of this, we put in hydrogen +1, accepting 2 electrons that were lost by zinc. We end up having H2 with the oxidation number 0. And we need to balance the amount of hydrogen ion, because each ion accepted 1 electron, and eventually it produced the hydrogen gas. Mass and charge must be conserved within oxidation half reaction and within reduction half reaction. Sometimes you can see the redox reaction written like this, the very bare bones of the reaction, because we are only interested in those species that changed their oxidation number. And we are not really need to know much about ions or elements that didn't change their oxidation number within this reaction. So here it is. And back to our conversation about conserved mass and charge, we can see here that we have mass conserved. We have 2 irons on the left, 2 irons on the right. 1 tin atom ion on the left, 1 tin ion on the right. So the mass is conserved, and the charge, if we look at the charge on the left, we have oxidation number plus 3 on the iron times 2 plus 2 the oxidation number on the tin, which together gives us 8 plus 8. And if we look at the product side, we can see that we have plus 2 oxidation number on the iron times 2, because we have 2 irons ion, and we have plus 4 oxidation number on tin. Together it gives us plus 8. The charge is conserved. So let's figure out what was oxidized, what was reduced. Well, in reduced thing, we should see the reduction of the charge, of the oxidation number. And we can see that the number of iron goes down. It's plus 3 over here, and it's plus 2 over here. So our oxidation number went down, so iron is reduced, while tin was oxidized. The tin lost 2 electrons and its oxidation number went up. Let's write the reaction for the oxidation half reaction. Tin with the number plus 2 was oxidized to tin plus 4, and along the way it lost 2 electrons. And when it comes to reduction half reaction, it is 2 irons with oxidation number plus 3 accepted those 2 electrons. They come right here to produce 2 irons plus 2. And here is another example of redox reaction. So we have lead here with the oxidation number 0. Here we have lead with oxidation number plus 2. So the oxidation number went up, so we can say that the lead was oxidized. Let's write the oxidation half reaction for it. P was 0, it became lead, oxidation number plus 2, and 2 electrons were lost along the way. And those 2 electrons that were lost by lead were picked up by copper. So the copper got reduced, and now it has oxidation number 0. Remember that mass and charge in oxidox reductions must be conserved. And I hope you now can write the half reactions on your own.